The GeoCore Institute of Engineering Innovation. My name is Sarah Basha, and I'll be presenting my design for the GeoCore Institute of Engineering Innovation, a next-generation research facility located in Tempe, Arizona. This project integrates regional materiality, passive performance, and an adaptable internal framework to support scientific advancement within an extreme desert climate. The chosen site is at the southeast corner of E. 8th Street and S. Rural Road, in mid-urban Tempe. This location was selected for its adjacency to a SU's research ecosystem, including the Biodesign Institute and ISTB-7, and its proximity to public transit and student housing. From the solar studies, you can see that the site receives intense sun exposure throughout the year. This drove many of the passive strategies in the design, such as the use of layered walls and louver systems, which I'll explain shortly. The surrounding urban grain informed my massing response, while topographic slope and pedestrian paths guided site access and garage entry design. The core design concept draws inspiration from a geode solid and protective externally, yet crystalline and experimental internally. This metaphor guided both form and function. The exterior envelope shields the building from harsh desert conditions, while the interior promotes transparency, innovation, and exchange. This duality also reflects the nature of scientific research, structured yet exploratory. The building program supports a wide range of engineering functions. It includes high bay labs, wet and dry laboratories, computational research spaces, lecture halls, retail zones and a public restaurant, administrative offices, and collaborative work areas. The labs are distributed to optimize adjacency, daylighting, and safety. Labs requiring more environmental control are pushed inward, while office and public zones take advantage of daylight and exterior access. The massing develops from a centralized atrium that acts as the core. This space provides natural daylight, acts as a vertical thermal chimney, and encourages interdisciplinary interaction. The geometry steps back in response to solar orientation. Louvers and angled apertures further modulate light and heat gain. At the urban scale, the building rises organically from the ground, mimicking a geode emerging from desert strata. This strategy enhances the tectonic reading of the building, rooted, layered, and expressive of material performance. On the ground floor, you can see clear zoning between public and private realms. Public exhibition spaces and collaborative lobbies are placed near entries, while labs and secured research areas are located deeper within the plan. Restrooms and mechanical shafts are efficiently stacked to reduce utility distribution complexity. Upper floors continue the zoning logic labs, and research areas are buffered from offices by corridors, while vertical cores provide clear wayfinding and emergency egress. The building operates with a boiler and chiller system, paired with a variable air volume (VAV) system. This was selected for its ability to manage the varying thermal needs of wet and dry labs. Mechanical shafts are centralized to maintain clean ceilings and minimize duct lengths. The exterior envelope includes high thermal mass materials, rammed earth, and exposed concrete, enhancing passive cooling, especially at night. Louvers respond dynamically to solar orientation, helping reduce the cooling load while maintaining visual and daylight comfort for lab users. The shell is made from regionally sourced rammed earth and steel, referencing local construction heritage while maximizing thermal inertia. The translucent upper portions of the envelope filter natural light, much like quartz within a geode. The form encourages stack ventilation through the atrium and integrates photovoltaic potential along the sloped rooftop. This combination of tectonic clarity, regional responsiveness, and research adaptability defines the environmental and architectural identity of the GeoCore. In conclusion, the GeoCore Institute is a speculative yet grounded vision for desert-based innovation. It merges high-performance research demands with cultural and climatic specificity, offering a tactile, spatial, and sustainable response to the challenges of our era.